Okay, everybody, this is a small section of class notes. They're not necessarily split out as class notes in your notes packet, but go ahead and get into chapter 23 of your notes packet. And the second page of chapter 23, we have 3 processes that I want to just go through in detail. All of these are called addition reactions. So search for that vocabulary word, upper half of the page. An addition reaction is when you add a substance to a double or a triple bond of an alkene or an alkyne. Okay, so that definition you got from the book, you're adding a substance to a double bond or to a triple bond in either an alkene or alkyne, and you're creating a new molecule off of that. Now, 3 specific examples were given: hydration, halogenation, and hydrogenation. Okay, well, when we think of hydration, we think more about our own selves and how much water we have. So that's what we're doing with an alkene as well. When you have hydration, you are adding water to an alkene, and it always produces an alcohol. So just walk through that process real quick. This is our simplest possible alkene, just 2 carbons, that's ethene. We're going to add water to this double bond. We're going to add water to the carbons that have that double bond. Okay, now what I'm going to do is I'm going to erase water here, and I'm going to rewrite it in a different way. Okay, I'm going to write it as HOH. Okay, so water can be written this way. It is a formula that can be used to show several things. For example, we know acids start with hydrogen, bases end with hydroxide, and when you have hydrogen and hydroxide, you get that ultimate neutral compound of water. But in this case, I'm drawing it this way for a different reason. This is where water is going to split apart, H and OH, and one of those pieces is going to come over here and bond with this carbon, and the other piece is going to come over here and bond with that carbon. And so go ahead and be sketching this example out if you didn't have it already. Okay, so when this happens, that double bond is going to go away. We can't have a double bond and have these attachments to the carbon, because that would make 5 bonds around each carbon, and we can only have 4. So that double bond becomes a single bond, and we're going to end up with our 2 carbons with a single bond. They both still have their original hydrogens attached to them, so I'm going to throw those on there. And now this hydrogen is attached just the way that I drew it to this carbon, and this OH is attached over here. And we know that an OH attached to a carbon is going to signify an alcohol substance. And that is one of our functional groups. Okay, so in hydration, we form an alcohol. Okay, now we don't normally think about alcohol being hydrating, but that's not what's happening. We're adding water and it's creating an alcohol. Okay, so this would be ethanol. All right, the other 2, super similar. These are all addition reactions. The mechanism is the same. We're just adding something different. So halogenation is the addition of a halogen, again, to an alkene, and it produces a halocarbon this time. Instead of producing an alcohol, we're producing a halocarbon. Okay, so let me back this picture up just a little bit. I'm going to erase my product and my water there. Okay, just going to show a halogenation process. So hopefully we remember our halogens are group 17. So you've got fluorine, chlorine, bromine, iodine. Okay, it doesn't really matter which one you pick for the example. I'm going to pick not chlorine because chlorine has C's in it, and then we get confused with carbons versus chlorines. I'm just going to pick bromine. Now remember, halogens, all of our gens, when they're in their pure form, are going to exist as diatomic molecules. So it would be Br2 would be bromine. Now, if I were to just change that into a structure, instead, I'll have Br, single bond between those 2 bromines. Throw on those valence electrons if you want to make it a Lewis structure, but this is going to do the same thing. My molecule here is going to split and attack the 2 carbons, and that's going to get rid of that double bond. So this bromine is going to end up attached to one of my carbons. This bromine is attached to the other. It doesn't really matter which one goes to which, but that double bond has to disappear to keep our carbons at only 4 bonds. So giving my single bonds for my carbons, put my 2 hydrogens on each carbon because they don't lose those. And then I go ahead and I add my bromines, 1 to each carbon. Okay. Again, what side you choose to put the bromine on versus the hydrogen does not matter. A single bond has rotation in space, and so it really does not matter which one is where. Okay. But we have formed a halocarbon because a halocarbon is a hydrocarbon that has a halogen replacing at least one of those hydrogens. So if these two were hydrogens, that would be an alkane, but because they are halogens, this is a halocarbon. Okay. Then the final one, hydrogenation. Again, this is just hydrogen, adding hydrogen to an alkene, and it's going to make an alkane. So again, this time I'm just going to erase my BRs here. Hydrogen, another gen, is diatomic. So there's my hydrogen molecule, H2, right? But I wrote it out as H bond H, okay? Those again are going to split and attach onto those 2 carbons, and we're going to end up with an alkane because we just changed our double bond to a single bond, and now we have all hydrogens and carbons, so that is an alkane. Alkane is a hydrocarbon with all single bonds. Okay, so the mechanism is the same on all of these. When you add addition reactions, when you add something to the carbons of a double bond or of a triple bond, you are going to reduce that bond. Okay, you're going to change a double into a single, or you could change a triple into a double or a triple into a single. An addition reaction reduces bonds in the molecule, and you end up creating a substance with that reduced bond structure. Now, if you're reducing with hydrogen, you go from an alkyne to an alkene, or an alkene to an alkane. If you're reducing it with water, you're creating alcohols. If you're reducing it with halogens, you're creating halocarbons. But it's always going to reduce that bond when you do an addition reaction. And that's the end of those notes. So hopefully that makes more sense. And ask questions, obviously, if you ever have any.